Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the Talk to My Documents demo you can stand up in an afternoon. And the slow, 6-month realization that the demo was lying to you.
So we already know RAG from the Gen AI lesson. Chunk, embed, store, retrieve, generate. What's different here?
The question this time isn't what is RAG? It's what does RAG look like when you wire it up in LangChain? And where do real teams diverge from the framework? Because LangChain hands you a clean primitive for each of those 5 stages, and they snap together so neatly, the whole prototype fits on one screen.
Walk me through the snapping. Stage 1 is getting the documents in.
Loaders. A loader's job is to normalize stuff on disk into one shape LangChain calls a document. And a document is honestly just 2 fields, page content, a string, and metadata, a dict. There are loaders for PDFs, websites, Notion, S3 Slack, GitHub, 100 sources, all funneling into that same document shape.
Hold on. That metadata field sounds like an afterthought, is it?
It is the opposite of an afterthought. And that's the first thing people underrate. Load a PDF and each page comes back with metadata saying source equals contract.pdf, page equals 0, page equals 1. Later, that metadata is how you filter retrieval. Only chunks from this one customer's docs. And it's how you cite sources back to the user. Production rig without metadata is essentially undebuggable.
Okay, stage 2. Splitting. Why split at all if the loader already gave me the document?
Because a loader gives you one document per page or per file. And that's almost always far too big to embed usefully. So you chop it smaller. The workhorse is the recursive character text splitter, and the recursive part is the clever bit. It has a priority list of separators. Paragraph break first, then single new line, then a space, then bare characters, and it tries them in order. Split on paragraphs. If a piece is still too big, drop to new lines, still too big, fall 2 spaces.
So it's trying to break at the most natural seam it can find and only resorts to hacking mid-word as a last resort.
Exactly. It respects the document's natural joins as long as it can. And it has 2 knobs. Chunk size is the big one. Genuinely the most important knob in your entire rake pipeline. Usual starting range is 200 to 1,000 characters. And the lesson is firm. Don't guess it. Sweep it against a test set and measure recolatk.
And the second knob?
Overlap. Each chunk repeats a little of the previous one's tail, typically 10 to 20% of the chunk size. It stops a critical sentence from getting guillotined right at a boundary, half in one chunk, half in the next, and lost to both.
Quick subtlety. You said chunk size is in characters, but isn't the model's real limit in tokens?
Sharp catch, and yes. By default, the splitter counts characters with plain lay. If you want token-accurate limits, you swap the length function for a tokenizer like TikTok, and now the same knob counts tokens instead. And one more. For code or markdown, don't count characters at all. Split on structure, per function, per heading. Structural splitting beats character counting whenever the document actually has structure.
Right, then embed and store. That's the back half.
And it's almost anticlimactically short. You hand your chunks to an embeddings model, it turns each into a vector, and you pour them into a vector store. One call, from documents. Chroma's the easiest one locally. In production, you'd reach for Qdrant, PageVector, or Pinecone. But the LangChain interface is identical across all of them, which is the point. From documents, as retriever, similarity search, same 3 methods, whichever store you picked.
And retrieval? The store hands me back a retriever and I bolt that onto a prompt.
Every vector store gives you a retriever with one call. At query time, it embeds your question, finds the closest chunks by cosine similarity, hands back the top few. You stitch those into a context block, stuff it into a prompt that says, answer using only this context. And if it's not here, say I don't know, and call the model. Load, split, embed, store, retrieve, generate. Maybe 20 lines with the real classes. Fastest demo in town.
So if it's 20 lines and it works, why do teams ever leave it? You hinted this demo lies.
Because the defaults aren't tuned for your corpus, and you find that out the slow way. The pattern is so consistent, it's almost a law. A team writes the LangChain demo in an afternoon and ships it. Then, months in, they realize chunking is wrong, recall is bad, and they start swapping pieces. A smarter document-aware splitter, hybrid retrieval, keyword search fused with vector search, because pure embeddings miss exact terms, and the single highest leverage add, a re-ranker.
A re-ranker, that's a second pass after retrieval, reordering the candidates?
Right. A cross-encoder that looks at the query and each retrieved chunk together and rescores them properly. It costs a little latency, and it's almost always worth it. And here's the kicker. LangChain actually supports all of this. Hybrid retrieval, re-ranking, observability through Langsmith. Teams still often roll their own because they want to tune the merge, weights, and plug into their existing search infra.
So the honest takeaway isn't LangChain breaks at scale. It's the skeleton stays, you just replace the meat.
Beautifully put. That's exactly it. The loader splitter to retriever skeleton survives. The pieces inside get swapped for custom code as you invest in retrieval quality. And the lesson calls that a fine outcome. The actual mistake is to skip the prototype and over-engineer from day one.
One more thing nagging me. We trust the retriever a lot here. What if the right chunk just isn't in the top few it returns?
Then you're sunk, and no prompt engineering saves you. If the answer isn't in front of the model, it can't use it. Which is why most RAG bugs live upstream of the LLM in retrieval. You evaluate Ricolatke separately from how well the model writes. And for anything user-facing, add citations. Make the model cite sources by number and pass the real source back. Because without citations, a confidently wrong answer is indistinguishable from a correct one.
So the one sentence?
LangChain snaps RAG together in an afternoon, and that's its gift. But chunk size is your biggest lever. Retrieval is where the bugs hide, and the production system is the same skeleton with the meat swapped for your own.
Prototype fast, productize on purpose. That's the Datarekha audio guide. See you in the next one.